Okay, good morning class. So today we're looking at 9.3, the problems that you had with the even numbers, and then the class test that you guys did miserably in the day before. Okay. We couldn't have done it yesterday because of load shedding. Alright. So I was reminded about it. I tried my best to forget about it. You know, the marks wasn't that wonderful, or was it? Oh, I thought you pulling your face because yours was wonderful. Oh, it wasn't. So let's get into it. This was class test 5. Yeah. Class test 5. The question says solve for x. People, we spoke about k substitution. Not so. Not so? So, you should see x squared minus 2x in this, which is 2x squared minus 4x. What's the difference? For 2. It's a factor of 2 being multiplied through it. Well, I'm going to take a factor of 2 out. So we got 2 into x squared minus 2x as your denominator. So what we have now is x squared minus 2x minus 6 over 2 into x squared minus 2x minus 2 is equal to 0. So what do we do now? Now we can say let k equals x squared minus 2x. Not so? So what would we have then? We have a k here. So k minus 6 over 2k minus 2 is equal to 0. Can you all see that? So we write exactly that down. Which is now k minus 6 over 2k minus 2 is equal to 0. So what do I do now? What do I do now? LCM. And what's my LCM? 2k. Alternatively, I could have simplified that and say that is going 1 and 3. Then my LCM would have been k. Can you see that, people? But since the call was for 2k first, just go with 2k because the sum is not really large. There's really a small one, small equation. So the LCM is going to be 2k. Of course, my restriction is k can never be equal to 0. You multiply throughout by 2k, it's going to get 2k squared minus 6 minus that's going to multiply by 2k, which is 12k, equals 0. I'm going to divide by 2, and then rearrange, gives me k squared minus 6k minus 3 equals 0. I made a mistake here somewhere. Sorry? How do I get 12 here? That's the mistake. Supposed to have been 4. Thank you. So that gives us a k value, k and 3, k and 2, and 1, minus and plus. So k is equal to 3, or k is equal to negative. But they haven't answered the question. No, the question was to solve for x. So looking at this here, if k is equal to 3, but k is x squared minus 2x, then that means you say x squared minus 2x is equal to 3, or x squared minus 2x is equal to negative 1, which is the other root. Okay? Yes? Sorry?
Does the 2 that you factorize out of the trinomial follow?
This here?
Yes.
I must divide it by 2. Yeah. So it's going to go right through. Divide by 2, I get this here. Okay? Answers your question?
Yeah.
Okay. But if you're going to use your quadratic formula, would I need to divide by 2? No. People, we bring this 3 over. Gives us x squared minus 2x minus 3 is equal to 0. Trinomial. So you got x and x, 3 and 1. Minus plus. So x equal to negative 1 or x equal to 3. Okay. On the other hand, we bring that over, it becomes x squared minus 2x plus 1 is equal to 0. Okay? So there's a perfect square trinomial. So x is equal to, or x minus 1 squared is equal to 0. Therefore x is equal to 1. Okay, you guys understand? So should you be able to have done the sum? Yes. We spoke about case substitution. Okay? Let's carry on with the next question.
So,
Yes?
exam,
Yeah.
like this will definitely be equal to 0 marks.
Could be 5 marks, could be 6 marks, could be 9 marks. Yeah? Depends on the complexity of the sum. Okay, the sum is very complex and we must push up your mark. A lot of steps, a lot of calculations involved. Okay. And can you see the amount of work that went in for 7 marks? Some of you write one answer and then you think, yes, you come out that paper. You say, yes, I answered everything. No? Then you think, okay, the maths is in the bag. Then you realize the bag has a hole in it. A big one. People, again, what is important here? Going through past papers. Very important. And again, if you can't use if you don't know how to factorize, feel free to use the quadratic formula as needed. Don't let anybody tell you otherwise. I know some people are saying, you will be penalized, marks, and talking nonsense. Use the quadratic formula. Okay. People, question 2. For which values of k will 4x squared minus 4kx plus 8k plus 8x plus k squared equals 16 as real? The roots are dependent on what? What is this question 3? Is it okay if I do question 3 first? No, I'm feeling better, you see? So, what is the roots dependent on? What's the roots dependent on?
Delta.
Yes, delta here. Whisper loud for you guys, you can hear. So when I say it loud, you also don't hear. So hopefully when I whisper, you're loud. People, delta. Delta is what? B squared minus 4ac. And it can only be retrieved from the equation if it's in standard form, which is ax squared plus bx plus c. So, the a is sorted, the a is formed. Okay, here we got x's. So we got 4x squared. We're going to take out x as a common factor. So I say plus minus 4k plus 8 x plus k squared minus 16 equals 0. So what's my b value? Negative 4k plus 8. What's my c value? K squared minus 16. Not O, it's a K. No? So what did we say? Delta. Delta is what? B squared minus 4ac. So what's my B value? Negative 4k plus 8 squared minus 4a is 4. C is k squared minus 16. So again, a binomial squared is going to be 16k squared. That times that is 32 times 2 is negative 64. K plus 64, that's 8 squared. Negative 16 times k is negative 16 squared. Negative 16 times negative 16 is positive 16 squared. Or I think it's 256 if I'm not mistaken. No? So what happens now? We add like terms, that cancels. So it's negative 64k plus 256 plus 64 gives me 0, carry 1. 12, no? Carry 1. Is it 320? Check if you don't mind. So that calculation up until that point gets you 2 marks. Okay. Then we are told have real roots. Under what condition will roots be real? So we say for the real roots, delta is greater than or equal to 0. Yes. Sorry? Yeah? 64. Okay, yes, you are absolutely correct. Thank you. So for real roots, delta has to be greater than or equal to 0. What is delta? Negative 64k plus 320 is greater than or equal to 0. So we take 320 over. So negative 64k, again leaving the 4 out. Negative 64k has to be greater or equal to negative 320. So if I divide both sides, we divide both sides by negative 64. Remember it's negative, so what happens in inequality? Swaps around. So k has to be less than or equal to 5. Check if that's correct? Any problems here? Any confusion? Nothing. Okay. Let's look at number 2. Okay, number 2, there's 2 ways of doing it. I'll do it both ways. Firstly, you take out negative x as a common factor. I'm left with x minus 2. Your critical values here is 0 and 2. Not so? You don't write x equal to 0 and x equal to 2. This graph, is this graph smiling or frowning? Frowning, because that's negative. So it's 0 and 2. That's y is equal to 0. This says that x has to be less than 0, so it's below the graph. Continuous over break in solution? Break. So x is less than 0 or x is more than 2. There we go. Otherwise, looking at the way we normally do it, we first divide by negative. It gives you x squared minus 2x. Must be, remember, when you're dividing by negative, the inequality swaps around. Okay? X is a common factor. If x minus 2 is greater than 0, your critical values is 0 and 2. Do not say x equal to 2 or x equal to 0 there. Alright? If we had to use the quadratic equation, go straight to critical values is 0 and 2. Okay? So here the graph is smiling, you've got 0 and 2. That's y is equal to, that's more than 0, less than 0. This inequality says x must be, or the function must be, more than 0. Again, it's above the line. You see that? Continuous over break in solution. A break. So the solutions apart. So x is less than 0 or x is more than 2. Okay. Either way gets you that full marker. Okay. Question 4. We are told always the center of the circle. Giving reasons, answer the following questions. DC is perpendicular to AB. DC is perpendicular to AB, hence this perpendicular sign there. At E, DE is 18. DE is 18 units. AB is 24. But since that is 90, we know those lengths are equal. Not so? Why? Why? Perpendicular from center to chord bisects the chord. So that's 24. First question. Determine with reason the length of AE. So where is AE? Here. AE is this length. We know it's 12. So AE is equal to 12 units. Why? Perpendicular from center to chord bisects the chord. Okay? So there's 12. Let's look at question B. You all okay with that? I'll take it off. I'm going to paste B over that. So I'm going to keep the diagram in focus. Okay? If the radius of the circle is x, so if the radius is x, then this length is also x, and that length is x. Not so? So all those lengths are x. Express OE in terms of x. So OE is this length here. But if this whole length is 18, not so? D is 18. DO is x. So what is OE? 18 minus x. You all okay with that? So that's x. That is 18. So this length here has to be 18 minus x. No reason required. Okay. Let's look at C. In question C, calculate with reason the value of x. So looking at this here, we solve for x. So we can apply what in this triangle? The theorem of Pythagoras. So it's going to be x squared is equal to 12 squared plus 18 minus x all squared. Why? Because of Pythagoras with OEA equals x. Sorry, 90. We must say that that end is 90. Okay? So we're going to get x squared is equal to 144 plus 18 squared. That's 18 squared. Sorry? 324. That times 2 is negative 16x plus x squared. The x squared cancels. Take 16 over, come positive. 3 to 4 plus 144, yes? Negative 36. I looked at it as 80, so 18. You are correct. Okay? It's not 8, but 18. Okay. So it's going to be 36x. What is 144 plus 324? is 468. Is that correct? So x works out to be 4. No. Something with the 4. 13. Nothing with the 4. 13. 13. Okay. So was this paper even difficult? No. So you haven't stopped me and asked me to re-explain anything here. Which means to say you should have understood everything. Or gotten at least a better mark than what you did. Okay. Take that out. Then we went on to not grade 12 trigonometry. Sorry. Euclidean geometry. We got to theorem 3. Right? And we were busy with 9.3. Not so. Then I went through your books yesterday and I realized that none of you actually really did your homework besides one person. You actually really did it. It's actually sad. Because this is forming the foundation of many things to come in geometry. If you don't see one of these theorems in a diagram, or you can see that the theorem can be applied, you can be screwed for that whole diagram, or that whole question dealing with the diagram. So I don't know what's wrong with you people. Right, out of 9.3. So I went through your books, I explained to some of you where you're going wrong. Out of 9.3, let me just get the textbook up. Hello? Hi there. Okay, sorry about that. Which page were we on? To 87. So it was 9.3 on page 286. Okay, the even numbers you had to do. Any issues here with number 2? Number 4? Number 6? Number 6? Alright. Number 8? Number 10? Huh? Nobody had a problem with 10? You sure? You had a problem with 10? I tell you, many learners have problems with this in the exam. So I don't... probably realize that many of you are still not doing your homework. People, what's the use you pick maths, nah? And you don't want to work at the subject? Did you think this is like going to be a free ride, like hello, something? Which subject is a free ride? Like you don't have to do anything and you pass. Huh? All the subjects. You don't have to work in all your subjects and you pass. So there's no subject. And maths is a subject where you have to work twice as hard as everything else, which you're not doing. That is why you're not producing the mark that you need to produce. Or is it just that you need to tell your friends I'm doing maths and that's it? Huh? Further on, they don't know how much you get. You don't tell them how much you get and stuff like that. But anyway. Right, here we go. This is exercise 9.3 on page 286. Given that OAB and COD, so AOB and COD is your diameter. So if AOB is your diameter, then that angle is 90 degrees. Okay? And COD is the diameter, then this angle is 90 degrees. Not so? Then we are told that C1 is 33 degrees. Calculate the size of O3. So, as you can see here, angle at center is twice the angle at circumference. Okay. It's coming from, it's subtended by arc AD. Can you see that, people? So, angle at center is twice the angle at circumference. So, O3 is going to be 2 times 33, which is 66 degrees. Angle at center equals 2 times angle at circumference. There's 66 degrees.
So,
Yes.
what did you see the angles opposite equal sides?
So you got angles opposite equal sides. Then you got, so you first say that A1 is 33, angles opposite equal sides, radii. Then you say O3 is equal to 33 plus 33 or 2 times 33. Why? Exterior angle of triangle is equal to sum of the two interior opposites. So you use two theorems. And I used one. Okay. So you would have gotten 2 marks either way. However, if you had made a mistake on your reasoning, then you would have lost one of those 2 marks already. Okay. So applying the theorem is going to be easier. Okay. But yes, you would have gotten the mark anyway. Let's look at D. So if we're looking at D, D is this angle here. Again, you can go with A2 is equal to angle D, angles opposite equal sides, and then sum of triangles. Not so? Or, we can say that CAD is equal to 90 degrees. Why? Angle in semicircle. Then angle D is equal to 180 minus 90 minus 33, which is 57. Why? The sum of triangles, and it's triangle CAD. Okay, so there's 57. C, angle B. Angle B we can do exactly the same as this here. Okay? So we're going to say that ACB is equal to 90. Now many of you wrote angle C is 90. You can't just write angle C is 90. There's more than one angle at angle C. You see one, you see two, and the combination thereof. Okay? So it's not suffice for us to say just angle C. You guys understand? So CAB or BCA is 90, angle in semicircle. There is 90. but I don't have A1. Okay, so that's 90, so I can work out C2. So angle C2 is equal to 90 minus 33, which is, what's 90 minus 33? 57. No? Sorry? Yes. At 57 degrees. So angle B is then equal to what? Also 57. Why? Angles opposite, equal sides. And it's your radius. Its sides are equal. Yes? Then you lose one mark. Because was the sides given equal there? No, so who says it's equal? Why is it equal? Because it's a radius. Unless you first say that CO is equal to OB, radius, and then you say angle B is equal to 57, angles opposite equal sides, then it's also fine. Okay? Next one is number 10. In number 10, we are given that AOC is a diameter. So if AOC is a diameter, what can be concluded? That ABC, the whole angle ABC is 90. Again, you can't just say angle B. Okay? So ABC is 90 degrees. B and D are two further points on the circumference of the circle. Angle A1 is X, as indicated there. Write the following angles in terms of X. Right. So B1 is what? You see, those lengths are equal. So angle B1 is equal to X. Why? Angles opposite equal sides. The radius. Right. We didn't use that yet, no? Please look at B. O1. What do you say about O1? It's angles in a triangle. Not so? So you say O1 plus 2x equals 180. Why? Sum of triangles. This triangle BOA. So O1 is equal to 180 minus 2x. Let's look at C. Angle C. I'm going to calculate angle C. See, angle at center is twice angle at circumference. Can you see that, people? Put your fingers here on B and A. You run it to the center and back, circumference. You guys understand? Angle at center is twice angle at circumference. So angle C is going to be half of O1, which is 180 minus 2x. Angle at center equals 2 times the angle at circumference. Okay. Angle at center is twice angle at circumference, which makes that 90 minus x. Or we could have said that ABC, this angle is 90. Not so? So you must first say that ABC is 90. Why? angle in semicircle. Then you go angles in a triangle. So x plus 90 plus angle C is equal to 180. Sum of triangles, and then angle C is 90 minus 6. Okay. Then the next one, the next question they ask you to work out angle D. Angle D, same story. Angle at center is twice the angle at circumference. Did you see that, people? So angle D. I've used a theorem prior to this question, so I know that is simply 90 minus this. Angle at center is equal to 2 times angle at circumference. As you can see, especially with C, question C, there's more than one way of doing the answering the question. So as long as you're applying your geometry rules properly and you're giving your reasons, your correct reasons, you should get the full mark for the question. Alright? That basically brings us to the end of the work that is required for your exam. So for tomorrow, I would like you guys to do control test of last year. No, we didn't do that paper yet. No. So it's the control test of our school of last year, 2021. I'm going to do that paper tomorrow, but I'm going to first check your books if you did the work. If you don't do the work, it's useless. I'm doing the stuff. Okay? What? You say like, it's fine.
No, I mean,
What do you mean?
no, because that's even checkable.
So it's fine like to check tomorrow. But when I checked yesterday, it wasn't fine because the work wasn't done. How can I check it today if I just gave it? No. Oh, in your head you're saying, oh. No, I thought there's something wrong with me. Yet. Okay. Okay. People. Now imagine we still had to do theorem 4 for this exam, yeah? It would have made your life so much easier, you know that. You'll see when we do the theorem. Scared? No, I say it's going to become easier. Angle at center is twice angle at circumference. Is that it? Do you run your fingers on the papers? That's your problem. Yeah. Yeah, you just run your fingers. You play little games with yourself. No? On the paper. No? Then you'll see how simple it is. Very simple. Okay. Some of you don't want to play games. No? You stayed up last night. Now at least you're going to get full marks for your geometry section. If you listen, people, if you can do 9.3 to 9.1 to 9.3 each and every Sunday, inclusive of the proving of the theorem. Remember, in this exam is going to be one of the 2 theorems that you need to prove. It's either the theorem 1, which is the perpendicular from center to chord bisects the chord, that theorem itself, or theorem 2, which is angle at center is twice angle at circumference. One of those are coming in. So already I'm giving you 6 marks here. Yeah, if you can prove that theorem is 6 marks or 5 marks, depending which one comes in. Yes, Michael.
So let's say you have
Sorry. Let's say. Go. Yes.
And you figure out that you can use theorem 2. Can you use it?
Yes. You can use any theorem whenever, as long as you're applying it properly. That's why I say, you can apply, there's many ways of solving a question in trigonometry, geometry, many ways. You see, whichever way you decide, you can do it. Whichever approach you see, whatever you see on your script, on your question paper, that is the theorem you're going to use. If you see, okay, I see the theorem 2 can be applied, then you apply it. You see theorem 3 then you apply it. Okay. But very important is to do these exercises, so when we get to the cumulative exercise, where all these theorems, so they can ask you any theorem at any time, then you already mastered the theorems individually. Otherwise, many of you would have to go back to theorem 1. Because we can't teach you something if you don't know the basics thereof. You understand? So use this time to do the work. Okay? And I was sad yesterday when I'm crying.
So you want to cry?
No, I did cry. Telling you, listen, when I'm crying. Thinking that you people are supposed to be the best amongst us in maths, and you people are not doing the work.
So you make me feel a surprise.
You're going to surprise.
For the making so.
I'd rather stop this video. Because I was surprised in that class test of yesterday. You know, class test 5. Oh, yeah, good surprise. Okay. I thought the surprise I got from the class test 5, you're going to give me 4. Oh, is that why you didn't do the homework like yesterday? Is that why you don't speak in class? No, I must clear myself to check where are we with you guys. But further on, it's just as long as your mommy tell everybody you're doing pure maths, it was fine with you. No? Now is after you didn't do homework yesterday.
Yeah.
Nice. Alright, people call this a day. Don't forget for tomorrow, it's last year's control test, no? I think I'm going to start cutting it now already.